Alright guys, today we're going to be talking about something called the mass percent. We're going to try to calculate the mass percent. But first I want to start by looking at this element boron. Alright, when we look at the boron element, we notice that this number down here, the mass number, is a decimal. And if you look on your periodic table, you'll see that all of the elements, for the most part, they have masses or mass numbers that are decimal points. And so we can see that this one, it's 10.811. So you can't have 10.8 numbers of protons and neutrons, because if you remember, our mass equals our protons plus our neutrons, and these protons and neutrons have to be whole numbers. So we can't ever have a mass that's just a decimal point. So what this mass is, it's actually our average mass. So it's the average of all the different isotopes of boron. So usually in this one, we have some boron atoms that are 5 protons plus 5 neutrons. So they have a total of 10. So its mass is 10 boron. Okay. And we also have some that are 5 protons and 6 neutrons. So it has 11. So 11 boron. So you have some isotopes that are 10 boron in nature and some that are 11 boron in nature. And they have different percentages of each. And when we know the percentages, we're going to be able to calculate this average mass when we're given the percentages, okay? So you can take notes on this. I would suggest you do that. This is calculating the mass percentage. And so if you'd like to, you can label your notes that calculating mass percentage. You will be asked to do this on your test, so I would suggest that you learn how to do it. It's not too difficult. It's just as a few steps and kind of a lot of math. So I'd make sure you have a paper out to work on, a calculator out, and I'll start explaining how we're going to do this, okay? So in the problems that we give you, we're going to have to give you the different isotopes, and we're going to have to give you the percentage of each one. So let's look at lithium really quick. So if we look at lithium, there are 2 different isotopes of lithium. We have 6 Li and we have 7 Li. So remember this right here, it's the mass. So we have some lithiums that are 6 and some lithiums that are 7, their total weight. And so we know that our 6 lithiums is about 6 point, oh sorry, not 6. Let me erase that really fast. So we know that our total lithium is actually about 7.59% for 6 lithium, and we have about 92.41% of 7 lithium. So the 6 lithium are lithiums that are found in nature that have a weight of 6, and that's 7.59% of the lithium atoms are that much. If we look at the other 92.41% of the atoms found in nature, they're actually going to have a mass of 7. So we need to calculate our average mass. So the first step that we're going to do is that we're going to change our percent into a decimal so that we can, multiply and add and things like that. So if you don't know how to change a percent into a decimal, let me show you really fast. So what we're going to do is we're going to change this decimal point and we're going to move it 2 places to our left and put in a 0, okay? 2 places to your left. So we change our first decimal to 0.0759 and our second decimal is 0.9241. All right, so that is your first step. Let's underline that in red. All right, our next step is we are going to multiply. So step 2 is going to be to multiply. So what we're going to do is we're going to take this 6 and we're going to multiply it by its decimal, and this 7 and multiply it by its decimal. So we're going to take the 0.0759 and multiply it by 6, and we're going to take the other one and multiply it by 7. Okay, you just write off to the side what these answers are. I already did it earlier, and so I know that the first one is 0.4554, and the second one is 6.4687. All right. So you can do those on your calculator, double check, make sure you know how to plug these numbers in because you will be doing that on your test. Your final step is to add. So we're going to add up these 2 numbers right here, this one and this one, okay? So we're going to add them both together, and when we add them, we get 6.9241 as our total. You can put in units here at the back, but that's what we're going to do, and that's how we calculate the mass percent. So let's just do one more really fast. Let me give you some numbers. I would suggest pausing the video to see if you can figure it out, and then coming back to it and looking at the work I'm doing. So we're going to actually work with neon now. So neon has 3 isotopes, so this one we're going to do 3 with 3 different things. So we have 20 neon, we have 21 neon, and we have 22 neon. Remember, I would be writing this down if I were you. 20 neon is 90.48%. 21 neon is 9.25%, and 22 neon is 0.27%. All right, so our first step, remember, is we're changing these into decimals, so we're going to get a 0.9048, a 0.0925, and a 0.0027. Okay, that's our first step. Our next step is to multiply. So we're going to multiply this first one by 20, this second one by 21, and this third one by 22. Okay, so you can do this on your calculator. Like I said, I did this earlier. So this one is 18.096. This other one is 1.9425. And this final one is 0.0594. All right. So we got those, and now we need to do our final step, which is to add them all up. And when we add them all up, we get 20.0979. All right, so that is what you're going to be asked to do on your homework and on your test. Is they're going to give you these numbers and ask you to figure it out, and ask you to give them the mass percent, or give them the atomic mass, the average mass of the atom. Neon, or of the atom lithium or something, okay? So hopefully you feel comfortable with that. If not, feel free to shoot me an email, ask me a question, come in and talk to me, and good luck working on your homework.